All right, so with chapter 7 then, chapter 7 is actually an extension of our demand and supply analysis, basically going in and talking about from now on what we will call elasticity of demand. We will denote that by E sub D from now on. So elasticity is basically asking the question, or elasticity of demand is basically asking the question, how does quantity demanded change when price changes? Now, when you look at that particular question, hopefully you were sitting there thinking to yourself, well, wait a minute, didn't we already answer that on day one when we were going in and we were deriving the demand curve? Because we went in and said, hey, look, the quantity demanded of a good is going to be some function of the price. And so we went in, we did that entire analysis, we talked it through, and we said that, well, we have a negative relationship between price and quantity demanded. So we know that when price goes up, quantity demanded goes down, and when price goes down, quantity demanded goes up. So we've gone in and we've been drawing all of our demand curves to look exactly like that. All right. So the question, though, of elasticity asks something like this. If we all can agree that that is a downward sloping demand curve, then is this not also a downward sloping demand curve? Yes. Is this not a downward sloping demand curve? Right? And thus everything in between is going to be a downward sloping demand curve. So basically, the question of elasticity becomes, which one of these demand curves am I dealing with? Because as it turns out, depending on what I'm going to call the shape of the demand curve, the quantity demanded is going to change considerably from this demand curve to this demand curve up here. And look, let me show you what I mean by that. So if we go up, let's go in and let's take a demand curve that is relatively flat, looking something like that. Now, I do want you to note as you go through this analysis, I know every one of these demand curves that we have been drawing up until now looks just like this one right here. And I've been seeing that in your notes, and that's exactly what should be happening. But I will also tell you that when you start dealing with elasticity, when I tell you to draw a demand curve that is relatively flat, don't draw it like this because you'll never see the result, right? Make sure you draw one that is relatively flat, looking something like this. So exaggerate the curves so that you can actually receive the result that we're talking about. So because of that, I'm going to go in and I'm going to make this kind of large. So we have price and quantity. So I'm going to go in and I'm going to draw a demand curve that is relatively flat, looking something like this. So remember, normally I would kind of draw it like this, right? So I want one that's kind of flat in nature. If I get it too much flatter, I'm going to take up a whole lot more board. So I want you to notice, let's go in and let's just pick a particular price. Let's call it P naught. And so we know at that particular price, as you draw this over where it strikes the demand curve, that is going to be your quantity demanded of that particular good. Actually, right now, I'm just going to call it Q naught just to go in and keep things simple. All right, so there's our quantity at time period 0. Okay, now we know when price goes down, that quantity demanded is going to go up. So we're going to do this scientifically, right? I'm going to go in and I'm going to drop the price by a marker. Right, so P1, so price goes down. So now, though, if you take the price at P1 and draw it all the way across where it strikes the demand curve, that is going to be your new corresponding quantity. Well, I want you to notice that not only did the quantity demanded go up, the quantity demanded went up by a very large amount. So if this particular situation happens in a market, this is what we call elastic, T-I-C, demand. Elastic demand. And from now on, when you go in and you see the term elastic, I want you to think there is going to be a strong response to a change in price. There's going to be a strong response to a change in price. And of course, the exact opposite of this will happen as well. So if we're starting with P1 and Q1, so if you go in and you increase the price in this market, then when price goes up, quantity demanded will go down, but quantity demanded will go down by a very large amount, right? So we would still call it elastic demand, whether or not it's moving, the price is moving up or down. All right, so that's going in and looking at the demand curve that is relatively flat. So what would happen to the quantity demanded if we go to the other extreme where we have the demand curve that is relatively steep in nature? So let's go over here. Let me draw another demand curve. So we have quantity here and price. And remember, just to make sure that we get the effect that we're looking for here, we want that demand curve to be relatively steep. So I'm going to go in and I'm going to draw it, not straight up and down, but I'm going to draw it relatively steep. Okay, so clearly there's a difference between the shape of those particular demand curves. Okay, so if we go in then and we start out with the same price that we did on this other side, let's go on and start out with the price of P naught. If you draw this line over where it strikes the demand curve, there is going to be your corresponding quantity, however much of the good that happens to be. Now, the reason why I did the pen over here is because I want to go down and I want to have the same price decrease in this particular market, right? Ceteris paribus, all else equal. So the price is going to go down by exactly the same amount. Now we know, again, when price goes down, quantity demanded goes up. But now can everybody see that the quantity change is relatively small compared to what it was on the other side? So this amount right here. So in this particular case, if there's a relatively small response, then we would call this inelastic demand. So from now on, when you see the term inelastic, I want you to think there has been a weak response to a change in price. So the quantity demanded is going to vary, but it's going to be a relatively small response to that change in price. So does everybody kind of see where we're going with this then? Now the question becomes, why do we care, right? Because we know quantity demand is going to go down in both cases. So why does it matter, which one of these is actually going to happen? It turns out when you go out and look at government and business applications, both the government and a whole lot of businesses spend a whole lot of time, effort, and money going out to try to figure out what the demand curve for their product actually looks like. Because as it turns out, it has every bearing on what your pricing strategy is going to be in that particular market setting. So if you're going in, let's say, because most people believe, let's think about this for a second from a business's point of view, a lot of people would argue that, okay, if I want to go in and I want to make more money, then I would always decrease the price of my product. Because if I decrease the price, what happens to purchasing? It goes up, so then I make more money because I sell more units, right? Other people believe, well, if I go in and I increase the price of my product, I'm going to make more money. Even though I sell less of it, I make more money per unit, and therefore I'm going to make more money in general. Now, if you think about that for a moment, both of those sound relatively plausible, right? But the problem you get into is that you cannot both increase price and decrease price and decrease profits at the same time. That doesn't make sense. So somewhere along the line, we're going to have to take into account that consumers are going to be responding differently to the change in the price of those particular products. So businesses will go out. By the way, if you're bent towards statistics and you like this sort of analyses, that's going on, there are entire consulting firms that are out there that businesses go to and say, hey, what does the demand curve for my product look like? And they will go out in different areas of the country. They will gather data on price, quantity, and so on. They'll do the statistical analysis, and they will come back and tell you the demand for your product is relatively elastic, or the demand for your product is relatively inelastic. And that gives those businesses, and we'll do some examples a little bit later, that gives those businesses a whole lot of information about how to go in and price their product. And we're talking about $1 million studies, right? We're not talking about $50,000 or $60,000 or we're talking about multi-million-dollar studies to go out and figure out what these demand curves look like. On the other hand, the government really cares about this as well, because the government levies taxes on these particular markets to make money. And so they want to go in and they want to levy taxes on items that when you go in and in this particular case, if you were to raise the price, we know that people are going to buy less of it. But in this case over here, if you tax somebody and you raise the price, then you're not going to get as much tax revenue as you thought, because people are going to change their behavior. They're not going to buy as much of it. So the government particularly looks for goods that are inelastic in nature. That way, when they tax that product, a few people won't buy it, but generally that market remains stable and the tax revenue they get from that market is relatively high. So they want to know who's going in and who's, first of all, they want to know what their tax revenue is going to be, and they want it to be relatively stable. And they want to know who's going to be bearing the burden of the tax. And what I mean by that is a lot of people assume when the government goes in and they tax a particular item, let's say cigarettes, alcohol, right, whatever the case might be, that the only thing that happens is that the businesses raise the price by the amount of the tax, essentially going in and pushing the entire tax forward towards the consumer. So we believe, a lot of people believe that it's always the consumer that goes in and pays the entire burden of the tax. Actually, that is not only not true, there's only one situation that we'll deal with just a little bit later where it is true. There's only one. So what that means is when the government levies a tax on either cigarettes, beer, whatever the case might be, prescription drugs, right, so on and so forth, that people are going to change their behavior in one direction or the other. And when they change their behavior, that's going to be going in and saying that not only does the consumer pay part of the tax, but the person selling that particular item, the business, pays part of the tax as well. So that tax burden is shared. The question just becomes who bears the greatest brunt of that particular tax. So the government has a lot of stake in what these demand curves actually look like. So in fact, I'll bring in some studies just a little bit later. There's a very good chance that a lot of you have actually heard about these elasticity studies that have gone on. They actually print these in the newspapers and things. They don't necessarily call it elasticity because no one but us knows what that means, right? But they do go out and they give us the data for a lot of these different products. You've probably read about it and just never really put two and two together to know, hey, that's actually what they're talking about. How do we go out and how do we measure the change in quantity demanded? So I'll bring in some of those studies and show those to you just a little bit further down the road. All right, so So this is a big deal, right, that we have here. So we need to know how to go in and how to try to find out whether it is elastic or inelastic. Now, I have questions. Is everybody okay with the idea, right, that we're going for? Now, if we always had the demand curve in front of us, and look to see if it's relatively flat, look to see whether it's relatively steep, this entire process would be very, very simple. But it turns out very rarely do we ever have that. So we need to know how to go in and how do we actually measure and interpret this idea of the elasticity of demand. To do that, we are going to go in and take the percentage change in quantity demanded and divide that by the percentage change in the price of that item. The percentage change in quantity demanded versus the percentage change in price. Okay, so that's a big, long way to write this entire thing out. What you're going to notice in the textbooks, your textbook does this exactly the same way. Instead of writing this entire thing out all the time, they are going to go in and condense it. And so the numerator can be written as the percentage change in quantity demanded. Right now, by the way, when you're interpreting this, everybody knows what the percentage sign means, right? If you're not familiar with this symbol, this is the Greek letter delta. Delta always means change in. And then, of course, that's quantity demanded. So you can write it very, very quickly as percentage change in quantity demanded divided by the percentage change in the price of the item. All right, so it's a really quick shorthand mathematical way to go in and write the exact same thing. Okay, so how do we go in and how would we use a formula like this? So let's do example number one. Let's assume for the moment, assume the price of cars increases by 1%. In response, car purchases decrease by 2%. Can you see that? Yeah. All right. Assume the price of cars increases by 1%. And when that happens, car purchases decrease by 2%. All right, so we would ask ourselves the question, what's the elasticity of demand? So in this case then, the elasticity of demand is equal to, I'm going to go ahead and write it out to start, percentage change in quantity demanded divided by the percentage change in price. And then so we go in, we pick out our numbers, plug them into the appropriate spots. Sign becomes important here. So in this case, the price increases by 1%. So since price is in the denominator and price went up, we're going to put a positive 1% in the denominator. All right, so when that price increased by 1%, car purchases decreased by 2%. So in the numerator, the percentage change in quantity demanded is a negative 2%. Okay, so in this case then, negative divided by a positive is a negative. The percentages will cancel themselves out. And 2 divided by 1 is going to be 2. All right, so we come up with a number of -2. All right, and we're not done with that yet. We're going to come back to it in just a moment. But that's an example of, if you have the percentages, how you simply plug them into that very simple formula. All right, everybody good? Works the other way as well. So let's say we do example number 2. So let's go in and let's assume the price of gasoline decreases by 1%. In response, gas purchases increase by 0.2%. A second to write that down. Then the price of gas decreases by 1%. And in response to that, gas purchases increase by 0.2%. Okay, so if we take our simple formula, percentage change in quantity demanded divided by the percentage change in price. So in this case, I said the price of gas decreased by 1%. Again, since the percentage change in price is on the bottom, I'm going to put a -1% in the bottom, the negative sign showing the decrease. Then gas purchases increase by 0.2%. So the percentage change in quantity demanded is going to be a positive 0.2%. Okay, go ahead and do the math, the simplification. So the percentages will cancel. So we have a positive 0.2 divided by a -1 is going to give us a number of a -0.2. Now, I want you to note that these numbers that we're about to get, hold that thought for just a second. Hold on, I want to get ahead of myself here. All right. I want you to note, and the reason why I did both of these is, one of these I had the price going up, the other one I had the price going down. And in both of these, I actually ended up with a negative sign that popped out of it. That negative sign is important because when you go in and you look at that relationship between price and quantity demanded, we already know that's a negative relationship. Those two should be moving in opposite directions. So now that that negative sign pops out of this entire thing, we want to get rid of it. And so the very last step you do on any of these elasticity calculations is to go in and take the absolute value of the number. Can anybody tell me, what does taking the absolute value do? Makes it positive. So if the, what is the absolute value of a -2? It's going to be 2. If you take the absolute value of a -0.2, you get simply a positive 0.2. And these would be your final numbers for the elasticity of demand. So the other thing that you have to note about this is there are no units that came out of this. So the elasticity of demand is not a percentage. So you wouldn't look at this and say, well, that's 2%, right? That it's not that. It is not a dollar value, and it is not the slope of the demand curve. And we'll come back to that just a little bit later. So there are no units attached to this whatsoever. You would simply look at that and say, hey, if this happens in the car market, the elasticity of demand for cars is 2. If you go in and this happens in the gasoline market, the elasticity of demand is 0.2. And so what you end up with, and the reason why we took the absolute value, was just to get the overall change, the overall arcing change in price and quantity. So actually, the rule that you want to look at is the larger the elasticity of demand, the greater the response to a change in price. Sorry, Lucy. The larger the elasticity of demand number that you get out of that, the greater the response to a change in price. So in other words then, even though it's not the slope of the demand curve, we can actually go in and kind of speculate what that demand curve actually looks like. Because we can go in and say, all right, wait a minute. If the larger the number, the greater the response is, then that means the larger the number, is it the steeper or the flatter the curve is? The flatter it is. Because if you look at those first demand curves that I drew, the flatter they are, the greater the response. The steeper they are, the less responsive they are. So in this case then, since this number is well above the 0.2, then we can surmise that this demand curve is probably pretty flat in nature because it's a very high number. We can probably surmise that the demand curve for gasoline probably looks something like this because that number is very low. And so it just gives us an idea. It's still not the slope, and I'll explain that a little bit later, but it does give us an idea of what that demand curve actually looks like. Okay, so there's how we go in and take those percentages, take the absolute value, and come out with an elasticity of demand number, and how we actually go in and, to some extent, interpret what that number is actually trying to tell us. Okay, questions so far? Is everybody good? Now, you know, if this is where it all ended, we would probably be in pretty good shape, right? If you go in and if you were given the percentages, you can just plug them into this very simple formula and everything is all hunky-dory. Well, the problem that we get into in the real world is that very rarely do we get the percentages that pop right out at you. Right. So in other words, I mean, I've actually been noticing this over the course of the past couple of weeks. I noticed that the price of gasoline has gone from about $1.95 per gallon down to about $1.87 per gallon. Right. Anybody tell me what the change in price or the percentage change in price has been? Yeah, it's not that easy, is it? We got a formula, we can figure it out, but it's not like having it stared right in front of you. By the way, as the price has been going down, I've also noticed that the consumption of gasoline has gone from 3.2 billion gallons per day up to 3.75 million gallons per day. What's been your percentage change in quantity? Oh, bummer. Okay, yeah, so you're gonna have to work at it a little bit harder, right? To get those percentages that come out of it. And then we also have the unit problem that comes into this because some things are measured in gallons, others in pints, others in tons, in yards, and so on. So what we need is a relatively easy way to take those changes, those actual data, and then go in and figure out exactly what the percentage changes have actually been. Something that we can compare across different goods. All right, so here's what I want you to do. Sorry, Lucy, I'm gonna make you sick. All right, let's go over here, leave yourself enough room in your notes that you can put a column of numbers, one dealing with price and the other one dealing with the quantity demanded. All right, so we need some data to work with here. So let's say we go in and we have the price of 50 cents. Quantity demanded is going to be 25 units. The price of $1, quantity demanded is 20. $1.20, 18. $1.40, 16. $1.60, 14. $1.80, 12. $2, 10. $2.20, 8. I'm going to give you a second to write that down. Okay. So what we're going to have to do then is find a way, have a formula that we can plug in and actually convert the data over to an elasticity number. Now, the formula that we are going to use is what we call the arc elasticity formula. And that arc elasticity formula looks something like this. Now, first of all, I want you to notice this is derived from the formula that we've been using. So the elasticity of demand is going to be equal to the percentage change in the quantity demanded divided by the percentage change in price. So that is still the case. But now that we have both price and quantity we're going to have to deal with, we're going to have to be able to have something to convert those into our percentage changes. So here's how we're going to do it. First of all, for those of you who feel like you are mathematically challenged, or it's been a while since you've worked with this, right, so on, don't have a heart attack until I do an example. Okay, when I first put this on the board, I've lost a couple students at this point. Right? And people looking at it, oh my God, I didn't think I was going to be a math major, right? Right. But it looks really nasty when we get started. But I think once we go through and you do an example and then you look at it and you think, hey, that's pretty easy, right? As long as you get the formula written down right, it's pretty easy. All right, here's what we're going to do. Let's calculate the percentage change in quantity demanded. So to do that, we're going to take our quantity at time period 1, and we are going to subtract that from our initial quantity, Q naught. So Q1 minus Q naught. We're going to divide that by Q1 plus Q naught divided by 2. And I want you to put parentheses around the entire denominator. Because what do those parentheses tell us? You got to do that in one unit. That's one of the first things you do. You got to do it as a unit. Okay, so that right there will calculate our percentage change in quantity. All right, I'm going to put a big division sign here, right? That's that one, so I can make sure I separate everything. And then I'm going to do the percentage change in price. So I'm going to take my price at time period 1, and I'm going to subtract that from my price at time period 0. So P1 minus P0. Divided by my price at time period 1 plus my price at time period 0 divided by 2. And again, all of that is going to be in parentheses. Okay, so there's the formula that we are going to use to go in and convert our percentage changes. All right, there are 2 things that is important to note about this formula. Number 1, if you can remember this, quantity divided by price, Quantity is always on top, price is always on the bottom. I do not understand where this comes from. I can have people go in and work out this formula all day long and not have any problems with it. And for some reason, statistically speaking, 2 of you will do this in this class. You're going to flip this thing upside down. You're going to put the prices on the top and you're going to put the quantities on the bottom. I don't know where that comes from other than you didn't write the formula down to start. All right. So until you get used to using this, don't try to cheat the formula, right? Don't get lazy. Write the formula down, and then I think you'll see it's very intuitive where the numbers need to be plugged in. All right, that's number 1. The second thing I want you to note is, and what should make the formula a little bit easier, is that the top and bottom are actually mirror images of each other. Right? The only thing that's different is Q is up here and P is down here. Both of these have a negative sign. Both of these have the positive sign and divided by 2. So they're mirror images of each other. So that should really help things out. Okay, so what we want to know then in our example, so example number 1 here, assume price increases from $1 to $1.20. Assume price increases from $1 to $1.20. So the question would then become, if that's the situation, what is your elasticity of demand? Okay. Now, I'm just here to tell you this part right here is crucial in making sure that you get the right answer. It takes like 2 seconds to do, but if you visually get what numbers are what, the chances of messing this formula up, go down really, really quickly. You notice that we're starting at a price of $1. So if you come over to your chart, let's mark the initial price, P naught, at being equal to $1. It's right there in front of you. Well, if that's the case, then the quantity that goes along with that, Q naught, is going to be 20 units. Okay? So the price increases from $1 up to $1.20. So P1 is going to be equal to $1.20. But the quantity that goes along with it, Q1, is going to be 18 units. Okay, so if you do this little step right here, then all you have to do is substitute those numbers into that equation. All right, let's come back over here and let's do that. So if we go in and we start plugging numbers into this, we have Q1, which is going to be 18, minus Q naught, which is going to be 20. Divided by, okay, in the denominator, we have Q1, which is 18, plus Q naught, which is 20, divided by 2. And again, make sure you go in and leave that in parentheses. Everybody good so far? All right. On the bottom, we have P1, which is $1.20, minus P naught, which is $1, divided by P1, $1.20, plus $1, divided by 2. And again, a broken record, keep that in parentheses. So again, I think it's very intuitive that once you do that step over there, all you do is substitute those numbers back into this formula. Okay, before we start crunching the numbers, is everybody okay with where we're at right now? Okay, let's go ahead and start crunching. So in the numerator then, we have 18 minus 20, which is going to give us what?
-2.
All right, so we have a -2 on top, divided by, now be careful with this one. A lot of people with the calculators today want to plug into the calculator 18 plus 20 divided by 2 and enter, and you will get the wrong answer. Why? It's called the order of operations, right? So what we need to do with this is on the top of this, do 18 plus 20, which is going to be 38. 38 divided by 2 is going to give you 19. All right, so do 18 plus 20, enter, and then divided by 2. Do not do it all in one step. All right, on the bottom then, $1.20 minus $1 is, all right, 20 cents, divided by $1.20 plus $1 is $1.20 divided by 2, which is going to give you 0.6. Is that right?
It's 2.20.
Yeah, I started to say something you were right about that. $1.20 minus $1 is 0.2. All right, so $1.20, oh, I did plus, see, $1 is 2.20 divided by 2 is going to be 1.1. Thank you. Something looked wrong there. Easy to do. It's very, very easy to do. All right, now I do want you to note something for a moment. Remember in the examples we were doing before, that negative sign showed up at the end? All right, this is a very good check at this particular stage to make sure that, at least you got the numbers plugged into the right spots, because there's that negative sign that's starting to come through. Now, keep in mind, it could be on the top or it could be on the bottom, depending on whether price is going up and down. But there should be one and only one negative sign somewhere in this entire thing. So if you don't get any negative signs, you've done something wrong. If you get 2 negative signs, you've done something wrong. Okay, so that's a good check at this point. Then you can go back and start looking to see exactly what you did. So I've got 1 negative sign, at least we're on the right track. So let's go in, let's take our top, which is a -2 divided by 19. And that's going to give us, now, at this stage, I want you to put in your notes to round to the 4th digit. So if you do this, you get 0.10523, right, so on. I want you to take this and round it to the 4th digit. If we all do that, that takes away a huge chunk of the rounding error at the end of this entire thing. So 0.1053 negative, 0.1053. On the bottom, if you do 0.2 divided by 1.1, you're going to get a repeating decimal. This will come out to be 0.18181818, and so on. Take that and round it to the 4th decimal place. So the bottom will be a positive 0.1818. Make sure you take it to the 4th decimal place. Okay, is everybody good with this? Then if you go in, you take negative 0.1053 and you divide it by 0.1818, then you're going to get the number of 0.57920 and so on. At the very last stage of this, then, all the rounding error is taken care of, round it to the 2nd decimal place. And so you will get a negative 0.58 that comes out of it. All right. And then what is the very last step that we do on an elasticity problem? Very good. Take the absolute value. And so you're going to come out with a 0.58. And that is your number for the elasticity of demand. 0.58. Okay, so first of all, any questions about going through, simplifying this thing down, boiling it down? All right, so how do we interpret this number right here? It's relatively simple. If the elasticity of demand number that you get is greater than 1, then demand is elastic. If that number turns out to be greater than 1, then demand is elastic. So the larger the number is, the flatter the curve is, the more responsive people are to a change in price. If the elasticity of demand number is less than 1, then demand is inelastic. So the smaller the number is, the steeper the curve is, the less responsive people are to a change in price. And there you go. So there's going in and taking our elasticity equation, our arc elasticity equation, and then going in, taking a set of data, plugging it in, boiling it down, taking the absolute value, and then interpreting just how responsive these people are in this particular market. All right, so everyone good? Get your calculators out. You can do this in your notes so that you can have, so I'm going to come around, I'll grade it as we go. And when I get back down to my office, I will give you a quiz grade for this. Using the exact same numbers, right, that we have listed right here, the exact same demand curve. Assume price decreases from $2 to $1.80. What is the value of the elasticity of demand? And number 2, tell me, is it elastic or inelastic? Is it elastic or inelastic? You have 30 seconds. No, I'm joking. When you're done, when I've checked, you checked your work, given you the okay, we'll see everybody next Tuesday.